All right, so we're back with chapter 1, part 4. And so, as I mentioned before, pollution, air pollution, one of the things that gives it its strength is how concentrated is it, right? Is it a lot of carbon in the air? Is it a little? Is it a lot of sulfur dioxide? So, what are some things that affect that? Well, the actual geography around the area. Valleys, areas we have high sides, almost like a bowl, those can actually act to trap. Valleys can trap the air and any pollution in it, so it concentrates, especially if you get one of those temperature inversions we talked about. So temperature inversions form in valleys quite often. You have a valley, you have the high sides of the valley and the low part in the middle. And the high sides will actually sometimes warm faster and create that lid. And then what happens is, as you can see right here, normally the air gets warmer to colder, the pollution can just dissipate. But you get this temperature inversion. So it goes cold, 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 and then warm, and this becomes a lid. And it keeps all of this pollution right in this level right here. So here again, here's Salt Lake City. So how does this dissipate? Something happens. Maybe the wind shifts, blows it away. Sometimes the wind can blow it away. Sometimes the wind can actually concentrate. If the winds are constantly blowing a certain way, it will blow pollution right that way. So here's another example. These are mixtures of particulate matter and pollution from China. And we've been able to track them actually blowing across the ocean right over here to the west coast. So there's actually been a concentration right here of particulate matter with a Chinese origin or Mongolian or Asian origin because of the wind patterns. Now, this Clean Air Act of 1970, this was the very first national law that regulated air pollution. Before this, there were no laws on what you could burn, what you could put into the air. Your cars didn't even have to have a tailpipe. It's hard to believe that now. And there were laws. Factories could only release so many pollutants. Extremely harmful pollutants were changed. Okay, it's been very effective. Prior to 1970, gas used to have lead in it. It made the gas burn better. But what happens is that lead would get into the air, and as we know now, lead in the air can be very harmful for young children, but many other things as well. So it's been effective, and we can track since the 1970s that our air in this country has become actually much cleaner in many ways. But there's always been this kind of backslash or back criticism to it, is that to clean the air, to reduce air pollution, it's expensive. So cars now have a much bigger system for cleaning their exhaust. Some cars have 3 mufflers and 2 catalytic converters. They don't burn the same type of gas anymore. And so they have a lot of things that make it more expensive to build a car, but it's cleaner. Factories can't just burn what they want for fuel. They've got to be careful about it. So some people say that's expensive, and that expense hurts the economy. And it makes it very attractive for factories to move to other countries where they don't enforce these laws because it costs less. But the argument to that is that that may be true, but this is a short-term fix because in the long term, dirty air is much more expensive because of the cost of our health. And so we may not pay for it right now, but down the road we will. And when we measure various types of pollutions, carbon, nitrous, particulate matters, and this is from the 1990s, going back to the 1970s, you'll see this gradual general trend. For the most part, we've had a pretty significant drop. All right, so refrigerators. We're going to end this talking about exploding refrigerators. So the book starts with a human interest case study and ends with one. So CFCs, if you've never heard of these, CFCs are the chemicals, man-made, that allow us to have refrigeration and air conditioning. It's also what allows us to have fire extinguishers and aerosol cans. They were first invented in the 1930s by General Motors, who makes cars, and DuPont. Because before the 1930, the CFCs we used were also very flammable. So you would put these CFCs into a cooling system, but if there was a leak and a spark, they would explode. And before 1930, there were often reports of people being killed by exploding refrigerators. Well, this also meant you could not put air conditioning in cars because it was too dangerous. So they invented Freon, which was a brand new type of chemical, a chlorofluorocarbon. And it works, and it isn't flammable. But the problem is that over time, these CFCs, they're a gas inside the air conditioner. If there's a tiny little hole, they leak out. And they leak and they get into the air, and they kind of just hang out, they accumulate. They can last up to 1,000 years. Well, why is that a problem? In the 1970s, the scientists did research that said that these gases, they hang around, they take a long time to break down. And what happens is they end up in the stratosphere. And when they get into the stratosphere, the C, or chlorine in CFCs, it interacts with the ozone in the ozone layer and destroys it. And in the 1980s, we actually did research and found that over the North-South Pole, the ozonosphere had what they called a hole in it. You don't have to know all these chemical processes, but this just shows you that ozone is created and destroyed naturally by ultraviolet radiation, the sunlight. But when you add the CFCs, the chlorine kind of gets in there and it gums it up. And now it's no longer ozone, it's something else. And this just shows you the blue is less ozone. So there's this hole, this lack of ozone over the South Pole. And no one really noticed it at first. And that's because why? No one lives in the South Pole. And when they're down there, everyone is covered up with coats. They're not out there sunbathing, so no one's getting sunburns. But scientists knew that this was going to be an issue. If this got bigger and bigger, we'd have serious issues for the entire human race. And so we had a conference in 1989 in Montreal, Canada, the Montreal Protocol. This was one of the first international climate treaties. And what they did was 190 countries got together and decided they would ban making CFCs because they were too harmful. And what happened was we would switch to a new type of app. We would switch. So no more CFCs, which also meant, by the way, no more spray deodorant. I used to be able to have a spray deodorant can. Now they're very rare because you don't use CFCs anymore. And what we did notice was, beginning in the early 1990s, the level of CFCs in the atmosphere began to drop and ozone began to rise. And so right here, we start making CFCs, it begins to drop, and we predict that by the year maybe 2030, it'll be back to where it was. So very, very helpful. Okay? Because if we got rid of the ozonosphere, the ultraviolet radiation from the sun would make life impossible. We'd start seeing more and more issues of skin cancer. It reduces the immunity, eye cataracts. Eventually, over time, it would affect plants, and it would destroy the foundations of the food chain. So you know what? We actually had a climate change treaty that averted crisis. But we switched to using HFCs for refrigeration, because we still have air conditioning. These are hydrofluorocarbons. What's the problem? HFCs don't destroy ozone, but they are 100 to 80 to 100 times more potent as a greenhouse gas. So we've actually just really traded thinning the ozone for global warming, which means back to the drawing board. So thank you very much for this video, and let's on to the next one.